Hey, I'm Brock Archer with Advanced Extrication.
And I'm Jim Bolton, captain with the Reno Fire Department.
Today we're in Fremont, California. We're at Fire Station 7. We're going to take a close look at the Tesla Model 3. It's a unique vehicle and it's electrically very different than Model S and Model X. I'm going to talk with you about the high voltage components within Model 3 and how to safely interact with them during your extrication assignment. I'll also talk with you about the SRS and airbag components.
Then I'm going to take you out to the training center where we're going to discuss the construction features of the Model 3, and then we're going to demonstrate a full side removal and a dash displacement.
Let's start by taking a look at the various high voltage components and their location in the Tesla Model 3. Okay, let's talk about the high voltage components in Model 3. It's important that we understand where the high voltage components are located so that we can avoid them during our extrication assignment. Tesla Model 3 is very different than the Model S and the Model X. We'll talk about those differences as we go through this high voltage component section. But let's start with the floor pan battery. The Model 3 has a full floor pan mounted high voltage battery. This battery is 400 volts. At no time during our extrication assignment should we breach the high voltage battery with our tools. This battery extends from axle to axle and rocker to rocker. Just like Model S and Model X, pushing on the floor pan of Model 3 is off limits. This can result in the floor pan collapsing and your tool interacting with that 400 volt battery. The seat mounts, however, where the seat mounts to the floor pan is a good push point for us, as long as we monitor it as we're pushing there. Also, the rocker channels or rocker panels on the side of Model 3 are good push points, as there's no high voltage cables in the rockers, unlike Model S and Model X. Okay, let's look at the location of all of the high voltage components on Model 3. It's been made pretty simple for us as rescuers by Tesla. All of the high voltage components on Model 3 are isolated to almost the center of the vehicle. The drive unit for the rear wheels is located between the rear wheels of the vehicle. The DC to DC converter, inverter, and charge controller are all integrated into the rear of the battery. That's found underneath the rear seat of the vehicle. The high voltage cables run up the center of the vehicle above the floor pan mounted battery. Again, the high voltage battery encompasses the entire underbody of the vehicle under the floor pan, axle to axle and rocker to rocker. Then in the center console area, we have the heater, the cabin heater for Model 3. This is located in the center console area of the vehicle. In front of the bulkhead, slightly towards the passenger side of the vehicle, is the AC compressor for Model 3. So you can see most of the high voltage component locations will not interfere with typical extrication assignments. Rescuers should avoid the floor pan of the vehicle for pushing off of. And in the center console area, the high voltage cables and the heater unit itself make the center console area off limits for pushing on the transverse bar or dash reinforcement bar in that area. Otherwise, Model 3 presents very little risks to rescuers with typical extrication assignments. Before we take action on an extrication assignment, we need to identify what type of a vehicle we've responded to. Are we dealing with a hybrid vehicle, electric vehicle, a propane, a natural gas vehicle, or just an internal combustion engine vehicle? It's important so that our course of action through our extrication assignment is safe and effective. So identifying the Tesla Model 3 is a little bit different than other Teslas. On Model S and Model X, you see Model X or Model S written on the back of the vehicle. For Tesla with Model 3, they've decided to use the SAE standard that allows them to use the unique name Tesla as the identifier to let us know that we're dealing with an electric vehicle. So what we know is that anytime we see Tesla on the back of a vehicle, that we're going to be dealing with a high voltage vehicle. Model 3 doesn't have Model 3 written on the trunk lid or the back of the vehicle. Simply, the Tesla logo is how we're going to identify it formally as a high voltage vehicle. We'll also see the Tesla logo on the hood, on the front trunk of the vehicle, so we can identify it that way as well. Our informal identification remains the same for Model 3. We may see orange high voltage cable, or we may see other high voltage components in the vehicle. Make sure that we identify our vehicles as electric before we take action on them, so that we can then go through the proper shutdown procedures to isolate that high voltage to the high voltage battery. Now let's take a quick look at the charging port on Model 3. It's located here, hidden in the taillight on the driver's side of the vehicle. The charging port opens automatically with a charging handle when you approach the vehicle and push the button. But it can also be opened manually by simply lifting up on the corner here. And again, there's the charging port for Model 3. This area is not high voltage unless the vehicle is plugged into a charger. The high voltage cabling for the charge port runs in the quarter panel of the vehicle here and then down through the side of the rear seats to the charge controllers. Okay, let's talk about the openings on Model 3. We have the trunk, hatchback area, the front trunk or the hood area, and then we've got all four doors. We'll start here at the trunk lid at the hatchback. To open the hatchback, you've got to have 12-volt power. There is an electric switch under the Tesla logo here that we can utilize to open up the trunk lid. If 12-volt power isn't present, this switch isn't going to operate. There's no mechanical linkage between a handle and the latch. We can, however, open this with the screen on Model 3. The LCD screen in the front of the vehicle will also open this, but it may be tricky for us to navigate at an extrication assignment. The occupant of the vehicle may also have an app installed where they can open the trunk with their phone. So if the occupant is conscious and able to help you with that, that may be another option for opening it. But if 12-volt power is shut down on the vehicle, we're going to have to force entry into the trunk lid. That being said, there is a small cable behind the interior of the trunk that can be pulled to open the trunk lid, but that's going to be tough to access at your assignment. The doors on Model 3 are similar to Model S and Model X in the way that the latches are electrically operated, but the handles are different. On Model 3, it's a mechanical handle, meaning pushing on the back of the handle will present the grip of the handle, and then we can open the door with the handle. It looks like this. Although the door handle does present itself like a mechanical handle, the latch itself is electrically operated in Model 3. This means that if 12-volt power is shut down to the vehicle, the electric latches are not going to function. In this situation, on the front doors, we need to reach inside and use the mechanical linkage operated handle on the inside of the doors. On the rear doors, there is no handle on the inside of the doors. So on the rear doors, we're going to have to force entry if 12-volt power has been disconnected. The only other option on the rear doors would be to take the interior off the doors and use the small cable to pop the doors open. There is a manufacturing cable inside the rear doors that can be pulled on to activate the latch mechanically. Otherwise, if 12-volt power is disconnected, we're going to need to force entry or use the inside latches on the front doors. Gaining access to Model 3 is different than other vehicles, even for the occupant. The occupant of Model 3 needs to use a key card for Model 3. This key card gets access to the vehicle by placing it on the B-pillar in the door sill area. Now, the occupant can also use an app on their phone to conduct this operation. Once they're in the vehicle, to put the vehicle in a ready-to-drive position, they can still utilize the app, or they can use the key card by placing it in the center console like so. For a rescuer, locating the key card, just like proximity keys, isn't important. If one is found, we can remove it from the area of the center console, but we don't need to hunt for one at an incident. Now let's take a quick look at the SRS and airbag components within the Tesla Model 3. Model 3 is equipped with two frontal airbags, one for the front passenger and one for the driver of the vehicle. Model 3 is also equipped with two knee airbags, again one for the driver and one for the front passenger. Curtain airbags protect both the front and the rear occupants. Both the front driver and the front passenger have side airbags built into the seats of Model 3. The SRS components are pretty straightforward in Model 3. There are two seatbelt pretensioners, one for the driver and one for the front passenger. These pretensioners are located on the side of the seat of Model 3. The inflation cylinders for the curtain airbags are located in the roof rail, just above the C-pillar. Model 3 does have inflation cylinders like most vehicles for the front driver's airbag and both knee airbags. Rescuers should avoid cutting or crushing any uninflated airbag for this reason. Shutdown procedures for the Tesla Model 3 are quite simple. First, we want to stabilize the vehicle. Make sure that we chock the wheels on the outside to prevent vehicle movement. This is important because electric and hybrid vehicles move silently. Before we take action at any extrication assignment, cutting or crushing on a high voltage vehicle, we need to perform high voltage shutdown. Remember that even after high voltage shutdown is accomplished, high voltage energy is still present in the high voltage battery. In addition, after high voltage shutdown has taken place, we should still avoid cutting or crushing any high voltage components or cabling. In Model 3, high voltage shutdown is quite simple. The cowling cover in front of the windshield is removed to reveal the first responder cut loop. This cut loop is easily identified by the cut loop tag. This loop is cut twice to avoid reconnection. This will shut down the high voltage components outside of the high voltage battery. In addition to high voltage shutdown, of course, we need to perform 12-volt shutdown. 12-volt shutdown is performed with the same operation, removing the cowling and then exposing the 12-volt battery. The negative terminal is then double cut again to prevent reconnection. Remember, high voltage is always present in the high voltage battery, and even after high voltage shutdown, no high voltage components should ever be cut or crushed on any hybrid or electric vehicle. For more information on the shutdown procedures for Tesla Model 3, take a look at the Model 3 Emergency Response Guide.
We're at the Fremont Fire Department training facility where we're going to discuss the construction features of the Tesla Model 3 and then demonstrate techniques for doing a dash displacement and sidewall removal. To my left, to assist us with this, we have from A Shift Fremont Fire Department Truck 57 crew. On my right, from Aurora, Colorado Fire Department, we have firefighter Paul Shoemaker. Next to him is firefighter Mark Hogan from Fremont Fire Department. And finally next to him is Captain Corey Wilson from the Fremont Fire Department. Now let's take a close look at the construction features of the Tesla Model 3. Unlike the Model S and X, the Tesla Model 3 is constructed primarily out of steel. There are a few features that are constructed out of aluminum. Those features are the door panels, the hood, and the crumple zones in the front of the vehicle. It's important for us to understand the differences between aluminum and steel and how aluminum reacts when we apply the extrication tools to an evolution. Now we're going to discuss the construction features of the bulkhead A-post assembly. The Tesla Model 3 has some reinforcement brackets located down in the lower portion of the A-post behind the wheel well that give it superior reinforcing strength. If we're given the assignment to do a dash displacement, we're recommending that you cut above those braces, somewhere from here to here. This is a little higher than what we typically have done. The B-post is constructed of dual-phase steel. This high-strength steel should not cause any challenges for our late model cutters, given the thickness of the metal. Furthermore, that same steel is down the A-post and encompasses the area around the windshield. Now we're going to talk about the rocker sill to floor pan assembly. The rocker sill is a very robust feature of the car, which is a great place to use as a push point when we're going to displace the dash. There are no high voltage wires that run through the rocker sill assembly. That makes it safe for us to place the tools there. The floor pan, however, has the battery underneath of it, and that is not a location where we want you to place any portion of a power tool to perform an evolution. The seat post attachment is an acceptable location to place a tool as a purchase point if it's monitored closely. Now we're going to bring the crew in and demonstrate a dash displacement and total sidewall removal. Now that the vehicle has been stabilized, the 12-volt system has been isolated, and the high voltage system has been isolated to the battery, the guys are going to come in and do a dash displacement evolution. When responding to any auto extrication, your size up is going to determine the actions your team is going to take. We hope that these demonstrations we've shown you has given you a solid foundation when you're challenged by an auto extrication involving a Tesla Model 3.
Remember that identification is the first step in maintaining safety for yourself and the occupants involved in the collision. We covered the high voltage components and their location, and we talked about shutting down the high voltage and isolating it to the high voltage battery. We also covered the SRS components and the airbags in Model 3. We hope that this information will be a foundation for maintaining safety and effective extrication at your assignments. We want to thank Tesla for supporting this training with the vehicles and the information needed for our development. We also want to thank the Fremont Fire Department and Captain Corey Wilson for helping us with the training development and providing a location for our training video. Take care and be safe.